Hi guys, welcome to chapter 13. We're switching gears and we're going to talk about oceans and beaches and things like that for a while. So nice change of scenery, so to speak. Haha. Anyway, we're going to cover section A today. And like I said, we're going to start talking about oceans. So, the planet is covered with oceans. About 71% of the Earth is covered with salt water. So these oceans are just these large bodies of salt water. And it's what we use to kind of separate the continents. It's how we determine the continents based on the oceans around it. An oceanographer is a marine scientist, and that word marine, let's see right here, always refers to the sea or the ocean. So whenever you see that mariner or anything like that, that's what it's referring to. So oceanographers are marine scientists that study anything about the ocean. So there's a lot of different specialties. The book gets into several of them. There's two that I wanted to highlight. One is a marine biologist, which you've probably heard of. They study any living thing with the ocean, so plants and animals. But also these marine engineers. And they do a couple things. They create the equipment and like the little submarines and stuff that the scientists use to study the ocean. But one of their biggest jobs is to figure out ways to get fresh water out of the ocean. So since there's so much ocean water, there's plenty of water, but it's not super usable because it's salty. And so they are always looking for different ways to take the salt out. That's known as desalination, and make the water potable. That just means drinkable. Okay, so it's a really important task they have. There you go. So potable means suitable for drinking. So all the salt water, all the oceans of the planet are technically connected. It's not like they're separated by land, but we do kind of refer to them separately. We look at these basins, so kind of these segments, and there's 5 different ones. Just 1, 2, 3, 4, 5. And those are the main oceans, the main basins. And so we've got the Arctic up top, the southern down around Antarctica, the Indian, the Pacific, and the Atlantic. And the Pacific is actually the largest of those 5 basins, okay? We also have salt water in other places, though. So we refer to seas like the Mediterranean Sea or the Caribbean Sea. And it's still a section of the ocean, but it's mostly surrounded by land. And so it's kind of an inlet that's filled in a little bit, okay? We've got 2 different types of sea level that we talk about. The local sea level is always changing. The high tide and low tide is always back and forth. And so it's kind of something that's reported on according to the time of day. But we've talked about this mean sea level before, that MSL. That's the average of all the high and low tides at a larger region. And that's what's used to determine the altitude or elevation of things, okay? All right, so we've got lots of land features to talk about, okay? So just the topography around the coastline. So if you look on page 309, this is some of the stuff that we're going to talk about, and some of the pictures that are there are helpful, okay? So the shore itself is basically the land that separates the coastal region. So this would be the coastal region and then the ocean itself. So the sandy part, that would be the shore, okay? The beach is a little bit more than just the sand, and we're going to talk about that on the next slide. So we'll get back to beach, okay? But as we keep moving our way out, we've got this thing known as the continental shelf. So remember, there's continental crust and then there's oceanic crust. When you're like in the early parts of the waves, so when you're walking along and you hit the water and you can go out a little ways, but you can still touch, you're still on continental crust, and that's known as part of the continental shelf. If you keep going much farther, and I'm not talking about it getting too deep for you to touch anymore, but if you go farther out, you've got this big drop off. Remember in Finding Nemo when they were so afraid of the drop off? That's where the continental crust transitions into the oceanic crust, okay? And so we get this slope. The continental slope is a much steeper downward slope breaking off from that shelf there, okay? Within those, we get these things known as submarine canyons, okay? So this little kind of rivet little thing going through there, this is underwater, so you don't see it, but it's extra erosion that's taken place, and so the water has taken away some of the shelf, and you get these little slot canyon kind of things. And creation scientists think that those were probably formed during the flood when so much water was moving in and out. It just eroded more in those locations. Okay. We keep going beyond the continental slope and we get to this continental rise down here. And so things are very steep with the slope, but then they start to taper off a little bit. And that's because this is still carrying a lot of sediment with it. Even though it's totally underwater, the movement of that water is carrying a lot of sediment. And so some of that sediment starts building up there, causing that slope to taper off some. And then finally, as we go out beyond that, you hit the ocean floor, and that's known as the abyssal plain. And it's very deep and relatively flat. We'll talk about some other features that are down there as well. Okay, so back to the beach, all right? The beach is the sand that you're on, but also the sand that's being covered by the water, okay? So kind of that whole region that you can walk around by is considered the beach. The shoreline itself is where the edge of the water is at any time. So the shoreline is constantly changing with each wave, with high tide and low tide, but it's right at that edge of the water that we would call the shoreline, okay? A berm is kind of the beginning of the sand. It's kind of the high spot. It's either that part where you'd well, actually the dunes, we're not going to talk about dunes. That'd probably be like the part that you have to like walk over to get to the beach. But the little bit of a higher dry area where you set up your umbrellas and your towels and your chairs or whatever, they only get hit when there's like crazy high tide or storm waves. Typically that's completely dry, and that's just known as a berm, okay? The beach face, that's the hard sand. That's that's where you go and you scoop the buckets to make your sand castles. And so it's wet, but it's not constantly underwater, and that's just known as the beach face. It's kind of the zone between the high and low tide. It gets covered at some points, but not all the time. And then there's these long shore sandbars, okay? We can see a couple of them here and here. The book talks about troughs too, but I'm not going to worry about that. So these sandbars are where these waves are coming in and crashing, you know, because they actually break at a couple of points. We're getting the last break right at the shoreline there. They drop off sediment, and so they create these little ripples of sand on the bottom there, called sandbars. All right, so we extend back, you know, past the beach, and now we're into deeper water. The movement of the water creates a lot of those features we just talked about, but there's also a lot of tectonic movement that causes different features on this ocean floor. A lot of which we've already talked about. Okay, so we've got the mid-ocean ridge, and remember that's that underwater mountain range, and it's really technically the largest mountain range on the Earth. It just happens to be under the ocean. There's several of them, but there's one like really crazy main one. That occurs at those divergent boundaries. Remember the boundaries that are pulling apart, and that's where seafloor spreading occurs. We also get these things called seamounts, and they're basically underwater volcanoes, but like they're like little hills. Sometimes they build up enough that they actually poke out of the water, but a lot of them are still completely submerged. And if that, excuse me, that little volcano shape has a flat top to it, it's called a guyot. Okay, so we've got that little guy right there. Let's see, what else have we got? Trenches. Okay, we talked about that also. Remember where subduction happens? It's when the continental plates come together and one sinks back under the other into the mantle. So it's convergent boundaries coming together. And so those trenches are low spots in the ocean floor. The mid-ocean ridge are high spots in the ocean floor. Okay. And then if you look on page 313 in your book, you see something called an island arc. And as these volcanoes build up and start poking up out of the water, a lot of times they're in a line because they're following along a plate boundary. And they cause these things called island arcs. And they're just kind of like a chain of small islands. And if you look at a map of Alaska, Alaska looks like it has a tail coming off of it. It's called the Aleutian Islands, and they are little volcanic islands, and that's known as an island arc. All right, Last thing to talk about is coral reefs. If you've ever been lucky enough to do any real snorkeling or even scuba diving, you may have seen some coral reefs, okay? So these are actually kind of like skeletal remains of an animal called a coral, and they're not true skeletons because they're not vertebrates, but these animals secrete this calcium-rich substance called calcium carbonate, and it gets left behind, and it forms these kind of like rock structures that other animals come and make their homes in and hang out in. So they're a lot of fun to snorkel by because there's all kinds of colorful fish that hang out there. In fact, if you look on page 316, you can see kind of an exaggerated view of a coral reef, but not too exaggerated. Most of these coral reefs are in shallow water, and sometimes they actually poke up above the surface. That's a picture of the Great Barrier Reef right there that I'll talk about in just a second. Fringing reefs form along the coastline. They're not too far away, okay? A barrier reef is one that forms a little farther out, and it actually kind of traps some of the water. So if I've got the coast, okay, that's like the beach, then I'm going to have some water. Okay, I've got some water. And then all of a sudden, this barrier reef builds up, okay, right here. And then there's more water past it. This becomes known as a lagoon, okay? And so it's a barrier because it blocks the current of the ocean from coming in. That Great Barrier Reef by Australia is huge. It's like 2,000 kilometers in size, okay? Very, very large. We also sometimes get these reefs that form something called an atoll. Atoll. You can say it either way. Atoll. Anyway, it's a ring of reefs that formed around an island, okay? So if you've got an island, here's our little island, and you've got these reefs that form somewhere out past the coastline. If something happens to this island, say it's a volcano and it collapses, you're left with this ring-shaped reef, okay? Or as the ocean level rises and maybe submerges that island, you're left with this kind of floating, not floating, but it's by itself. The island isn't in the middle of it anymore. And that's, like I said, that's an atoll. All right, that's it. Bye-bye.